Thank you, Your Excellency. Our next speaker is His Highness Prince Turki م.Saud Al-Saud, Vice President, King Abdulaziz City for Science and Technology. Your Highness.
Bismillah, wassalatu wassalam ala Rasulullah. Your Excellency, ladies and gentlemen, it is my honor and a great pleasure to join you in this very important international forum. I will be discussing the strategic priorities for the Saudi petrochemical industries. First, I will talk a little bit about King Abdulaziz City for Science and Technology and its role. And then I'll talk about the national plan for science, technology, and innovation. Then I will mention some of the petrochemical strategic technologies, and I will conclude with some of our research collaborations and products in this field. CAXT is an independent scientific organization connected directly to the Prime Minister, the King of Saudi Arabia. It was established in 1977, initially as the National Funding Agency, and later on it took the role of conducting applied research starting in the early 90s. Currently there are over 3,000 people at CAXT, mostly researchers and engineers and technicians. And the main responsibilities is to propose, implement the national policy for development of science technology, coordinate with government agencies and research centers in the kingdom to enhance research and exchange information and expertise, and to conduct applied research and provide advice to the government on science and technology, and support scientific research and technology development, as well as foster national innovation, technology transfer between research institutes and the industry, and foster international cooperation in science and technology. The Kingdom is the first in the region to establish a policy for science technology that was approved by the Council of Ministers in 2002. And the policy has 8 major areas: science, technology, and society, institutional structure for science, technology, and innovation, scientific research and technical development capabilities, transfer, development, and localization of technology, strategic and advanced technologies, scientific and technical human resources, diversification of financial support, and science, technology, and innovation systems. These are the 8 areas that the plan requires all the participants to submit proposals that can be funded through the plan. And for the first 5-year plan, there was about 8 billion riyals, or $2.1 billion allocated for these programs. And currently we have what's called an extended 5-year plan that will allocate 16 billion riyals, a double of that amount for the next 5 years. This, of course, there are so many players. There are the ministries, various ministries involved, the research institutions, the private sector, and the society. And by the way we divide those areas, the ministries are supported to conduct operational research related to the implementation of their duties. CAXT is responsible for technology development, product development, and commercialization, and universities are responsible for fundamental research. So all those roles are complementary. There is a little overlapping, but the national plan, national committee supervising the plan coordinate these activities. One of those 8 areas which has 2/3 of the funding is the strategic technology area. And we have identified 11 of those strategic technologies: water, oil and gas, petrochemicals, nanotechnology, biotechnology, information technology, electronics, communication and photonics, space and aeronautics, energy, advanced materials, and environment. So I'm going to just talk tonight or this morning, about the petrochemicals. So the objectives of the Saudi petrochemical industry is to increase the industrial sector's contribution to the national economy, to promote industrialization based on locally available new materials, raw materials, oil and natural gas, of course, develop economic linkages between the industrial sector and other producing sectors, add value to our abundant hydrocarbon resources, reduce the dependence of the economy on the oil sector, support and promote the transfer of modern technology. And through meetings and workshops, we have identified with all the participants, this is the academia, the industry, and governmental agencies, the technology priorities, which are in the critical areas of gas and oil processes, refining processes, clean fuel and process development. And the specific fields are cracking, isomerization, dehydrogenation, polymerization, and alkylation. In these areas, there are so many topics that have been identified, 55 areas. This is a list of them. People who are interested can have a copy of this presentation. And I will then talk about what CACS does. This plan is for the whole country, and research support, the funding support all the segments of the R&D community in the country, as I mentioned, research organizations, ministries, and national research such as CACS. One of the activities we have in international collaboration, we have a joint center with Oxford in petrochemical research, and this center concentrates in 5 areas: development of novel solid acid catalysts for alkylation reactions, catalytic CO2 conversion into valuable organic compounds instead of storage, and design and prepare series supported structured catalysts for fuel combustion, process for synthetic natural gas production from liquid fuel, and polymerization catalyst, especially single-site catalytic process. Other collaboration we have with IBM, several collaborations. One of them is organic catalyst for polymer recycling. And this, we have developed some catalysts that take the bottle to bottle using PET, and actually also converting it to PET again or to other products. And this will be commercialized in a few months. So the product has already been established. We also work with IBM on membranes for desalination as well. We have collaboration with the Italian Research National Council for Scientific Network, and this work is on membrane reactors for petrochemical processes for separation of gases. We have also collaboration with the National Academy of Sciences of Belarus, things related to recycling of rubber and plastic waste. And some of the products we have, for example, is fire retardant material using radiations through our Atomic Research Institute. We have developed a fire retardant material that is used for cables and wires, and this is now being commercialized through a company, a local company in the kingdom. We have also developed the shape memory material that can, with heat, change its shape and return its original shape as well. This has a lot of important applications in the future, again, using radiation for developing this product. We have also developed a clean fuel, using a nano catalyst, and it's environmentally friendly, free of sulfur, nitrogen, and aromatic compounds. And we are at the stage of scaling this up into a large pilot project. And we have developed various catalysts for converting gas into clean fuel, removing sulfur compounds from petroleum, dehydrogenation of paraffin, isomerization, catalytic cracking, reforming, alkylation, and hydrogenation. There is a lot of work at CACS in this field. And we have also developed, and we produce various types of carbon nanotubes, different dimensions, whether single wall, multi-wall, with various applications. Some of those applications in nanocomposites. This is good for aerospace industries as well as in automotive and construction, increasing the surface activity of the polyolefins catalyst, purification of water and air from impurities, storage of gases in batteries of the future, gas sensors, and electric circuits. And also, we have developed many products of nano coating that are used in various applications in resistance to friction, hardness. Its applications include metal coating, window shield, glass coating, and automotive metal products. Also, we have various products in plastic recycling, and what's called nanofluids, which are very interesting in various applications for heat transfer. Some of those are coolants in nuclear power plants, coolants in air conditioners to reduce energy cost, preparation of metal and metal oxide supported catalyst, and magnetic and electrical applications. Thank you very much.